What is T-beam? Welcome to Civil Engineering Edge. Today, let's understand one of the most crucial elements in structural design, the T-beam. A T-beam, or T-shaped beam, is a load-bearing structure made of reinforced concrete that resembles the letter T in cross-section. It is designed by monolithically casting the beam and slab together, where the slab acts as the flange and the beam as the web or stem. This unique shape allows the beam to resist bending more efficiently, especially in the positive bending region of slabs. T-beams are used where slab and beam are cast simultaneously, allowing the slab portion to enhance the bending capacity of the beam. Compared to rectangular beams, T-beams reduce concrete volume and increase the effective depth without increasing self-weight significantly. The reinforcement is generally placed in the stem, where tensile stress is maximum. In short, a T-beam optimally combines slab and beam action, reducing material usage while improving structural performance. It plays a vital role in modern buildings, bridges, and floor systems. Where we use T-beam. T-beams are widely used in multi-story buildings, bridges, parking garages, flyovers, and industrial structures where slab and beam systems are designed together for enhanced load distribution. In building construction, T-beams form part of the slab system in floor and roof frameworks where the slab acts as a continuous flange. This allows the beam to span longer distances while minimizing sag and deflection. In bridge construction, T-beams are often precast or cast in situ and are designed to resist heavy traffic loads. The T-section provides additional stiffness and strength without increasing the depth of the bridge deck. In parking structures and industrial facilities, T-beams efficiently handle point loads, machine vibrations, and distributed loads due to their monolithic nature. Their structural efficiency, reduced material requirement, and seamless integration with slabs make T-beams a practical and cost-effective solution in reinforced concrete frameworks. Steps to design the T-beam. Designing a T-beam involves multiple steps to ensure it safely carries bending and shear forces under service conditions. Here's a step-by-step design process. Step 1. Define design parameters. Establish the span length, load types live, dead, etc., support conditions, and allowable stresses. Select concrete grade, for example, M25, and steel grade, for example, Fe500. Step 2. Estimate beam dimensions. Choose the overall depth and width of the stem web. Determine the slab thickness, flange thickness, and effective flange width as per is 456 to 2000. Effective flange width equals least of span of 6, center to center spacing of beams, actual flange width. Step 3. Calculate bending moments. Use load combinations as per is 456 to calculate factored bending moment move. For continuous or simply supported T-beams, use appropriate moment coefficients or structural analysis tools. Step 4. Check neutral axis location. Determine whether the neutral axis lies within the flange or stem. If in flange, treat it like a rectangular section. If in the stem, calculate the transformed section using flange and stem properties. Step 5. Flexural design. Use limit state method to calculate the required area of tensile reinforcement asked using. Mu equals 0.87 F, Y asked D1 asked 5th BD mu equals 0.87 C dot F underscore Y. C data underscore AC, C dot D left, 1 a fracka underscore AC, C dot F underscore Y F underscore CK, C dot B, C dot D right mu equals 0.87 F, Y asked D1 F CK B dast phi. Step 6. Shear design. Calculate design shear force VU and compare with permissible values. Provide shear reinforcement Step 7. Check serviceability. deflection, cracking, and vibration checks. Ensure bar spacing and cover satisfy durability and fire resistance. Step 8. Detailing. Prepare reinforcement drawings and bar bending schedule for site execution. Proper detailing and execution are vital for performance and safety in real-world conditions. Benefits of reinforced concrete T-beams. T-beams offer several structural and economic benefits in reinforced concrete design. 1. Material efficiency. By sharing part of the slab as the flange, less concrete is needed in the beam section, reducing dead load and cost. 2. Improved load resistance. The flange increases the section's moment of inertia, enhancing bending resistance and allowing longer spans. 3. Integration with slab systems. T-beams act monolithically with slabs, resulting in better load transfer and stability. 4. Economical reinforcement. The depth provided by the stem allows optimal placement of tension reinforcement, minimizing bar congestion. 5. Deflection control. Higher stiffness due to T-section reduces mid-span deflection, especially useful in floors and bridges. 6. Architectural flexibility. T-beams can be easily integrated into a variety of floor layouts and structural systems. So, whether you're designing a building floor, a bridge span, or an industrial platform, T-beams deliver the perfect combination of strength, efficiency, and economy. Thanks for watching. If you found this video helpful, give it a like, share it with your fellow engineers, and subscribe to Civil Engineering Edge for more practical and insightful content. Keep building smart and strong.